These are mostly bacteria, and they form a clear halo zone. That means this bacteria is eating the plastic.
There's a rising tide of plastic polluting our waterways, scattered across ecosystems, that cannot be resolved by recycling alone. We've come to rely on this wonder material that has made possible the development of computers and phones and many advances in modern medicine. But plastic can take 20 to 500 years to break down. Fortunately, as Professor Tsai Pong has discovered, nature has started to step in and may be one of the answers to cleaning up our mess.
We are searching for the right microorganisms, or let's say genes or enzymes, to help us to degrade plastics efficiently.
He's come here to Dafeng Port on the coastal marshes of Jiangsu in China to search for collections of microorganisms that have evolved to be able to break down plastic.
As you can see here, there are quite a lot of polymers like plastic and lignocellulose here. And this would probably result quite a few microorganisms that are able to use plastics as their carbon sources.
Fungi and bacteria need carbon sources to grow, and plastics are composed of predominantly carbon. It was on a research trip in 2021, supported by a team of students from Nanjing Agricultural University, that a very significant discovery was made.
In our last sampling, we obtained 184 fungi and 55 bacteria that are capable of degrading plastics. Among them, many are distributed all over the world. But some, like Johnsia, they are quite local, and this kind of strains are quite new, and I think this is the new discovery because many of the strains, although we knew them, but we don't know that they have the potential to degrade plastic debris.
Fong calls this a plastosphere, a term coined by Professor Linda Amaral-Zettler, a marine microbiologist. First described in a 2013 study, it referred to a collective of plastic colonising organisms, but it's now expanded to include larger organisms which live on floating marine plastic.
The biofilm here is exactly what we are looking for because this is actually the community of microbes colonised on the surface of the plastic debris.
Plastic is made of long carbon molecules known as polymers. The length of these polymer chains determines the properties of each type of plastic. And polymers can be broken down into smaller chains, collectively known as monomers.
Bacteria and fungi, they don't have mouths like our animals. For such kind of samples, they have already formed biofilm on the surface of the plastic. They secrete quite useful enzymes to degrade the polymers. Then they will absorb the monomers as their carbon nutrients.
Enzymes are proteins that act as biological catalysts by accelerating chemical reactions.
The surface of plastics are super hydrophobic, while the majority of our enzymes are usually hydrophilic, so this allows very little space for enzymes to attach to the plastic surfaces.
Professor Tsai is working with his team to figure out how to engineer the microorganisms to more efficiently break down plastic. Helping gather samples in 2021 was Fong's PhD mentor, Dr. Irina Druzanina, who had encouraged him to research plastic degradation in